I just emailed you regards to the assignment. So for this part, you know how we increase the load?
Yeah.
Right here, you told us to use the same method as above, but do we keep it at this load or do we change it back?
Keep it at 25.
Okay.
Yeah.
Okay.
Is this class going to be about MATLAB or the like lectures?
So we're gonna be, it's kind of like an interactive MATLAB thing today. So yeah. Okay. All right. It's 5:30. Let's go and get started. All right. Good evening, everyone. How's everyone doing today? Good. Good to hear. All right. Oh, I turn on the display. I'm sorry. I have this whole thing up on here, but only the Zoom people could see it. Okay. All right. So plan for today. So we are going to be doing a shift. So we're basically all done with the direct stiffness stuff. Oh, of course, the projector has started up. I apologize. So today, we're going to be doing a review of MATLAB. Okay? So I did already kind of grade your guys' homework too. And I did see that actually quite a few of you have already used MATLAB. You seem actually quite comfortable with it, but I do want to make sure everyone's kind of up to speed on MATLAB stuff because we are going to be seeing it a lot more often from here on out. And of course, it's going to be a big part of your final project as well. Okay. So I don't know if it's going to take us the whole week. I did kind of block off this whole week just to be reviewing MATLAB. But I did want to make sure that we go over everything that you need to know. I have a couple of examples here, just so that we're all on the same page with MATLAB. Okay. Okay. So with that said, I did grade you guys' homework too today. I did have a little bit of time today to grade. I think I went through it a little bit too quickly because I did get a couple of emails with questions because I didn't really leave any comments just because I was just trying to get it done. So if you did notice something off about your homework too, great, definitely send me an email, and I will go and take a look because I was kind of right in between a couple meetings and I just tried to get it done, but yeah, I think may have gone a bit too fast. Okay. All right. Any questions I can answer before we get started for today? Okay. All right. So of course, if you want to follow along, you can open up MATLAB on your own computers and then just kind of follow along that way. Of course, if you just want to sit and listen to me talk about MATLAB for an hour, 15 minutes, you can do that as well. Or, if you're watching on YouTube, then, you can always pause and kind of go back around. Okay. Oh, actually, one more announcement. So I did notice that there was an error in one of my solutions of homework 2. So if you're doing problem 3A, the solution I had was incorrect. And so I did correct that I did upload an updated homework document, and so that one has the correct solution. So I apologize for any confusion that may have caused. Okay. All right. So let's kind of jump right into it. So I'm kind of back to using slides just because with MATLAB it's kind of hard to switch between the iPad and the computer. So I'm doing on slides here. Okay. Okay. All right. So just to kind of take a step back, and to kind of just motivate why we're even using MATLAB in this class. So I would characterize finite elements as belonging to the branch of engineering called computational engineering. So computational engineering is basically when we use computers and computer software to augment our work. Okay. Now, this had a very different definition, when I first made this slide about 5 years ago. Now, when you talk about computational engineering, I think a lot of people tend to ask the question of, are we using AI? So this is not AI. So we're doing kind of the opposite of that, which is physics-based modeling. So we're basically going off our governing differential equations and solving them directly, as opposed to relying on an AI kind of predictor to do that. Okay. And so in order to do computational engineering, we do need to write code. And of course, there are many coding languages available for engineers to use. So probably, the ones that are probably most used for most practical stuff is probably C++. That's probably the most versatile and well-performing language. And so you get a really good balance of performance and ease of programming. Python is also a great option if you have a relatively light task that you need to do. MATLAB is honestly not used that much in industry just because it is very cumbersome language to run. So you can't really run any big codes in MATLAB, but MATLAB does make for an excellent educational tool. So MATLAB has a lot of built-in functions. It has a lot of extra packages that you can install to kind of make things easier. So that's why we kind of choose it for this class. But of course, if you're interested in learning another language and you want to complete the work in this class in another language, you are definitely more than welcome to do so. So all the examples that I have is in MATLAB, just because I think that's the most generally well-liked one. But if you want to do everything in Python, everything we do in this class, you can do in Python, you can do in C++. I guess technically you can do it in Fortran too, but I wouldn't recommend it. And then there's another language out there called Julia, which is kind of more, okay? Okay, so why do we use MATLAB? So MATLAB is a, technically, I guess if you ask a computer science person, technically MATLAB is not a coding language. It is what's called a scripting language, which is a very unique distinction. And so with scripting languages, basically scripts are basically read from top to bottom. So basically when you run a MATLAB program, basically what MATLAB is doing is it's interpreting your lines of code one at a time, going from top to bottom. With some exceptions, of course, if you have for loops, it may repeat code. If you have if statements, it may skip code, things like that. Okay. Now, scripting languages are always going to be slower than what's called compiled languages. And so C++ is what I consider to be a compiled language. So you compile it. But scripting languages are generally easier to use because it's easier to kind of find errors and iterate on them rather than having to compile and run a program. Okay. Python technically is also a scripting language, but it's much more optimized for performance than MATLAB. Okay. All right, but we use MATLAB just because it's just great for educational applications like this. Okay. All right. So this is kind of the kind of the reason why we use MATLAB, right? So one thing that's kind of underrated too is that there's a very strong online community that uses MATLAB. So a lot of times if you're struggling with anything, you can just kind of look it up online and probably someone has run into a similar issue. The documentation on the MATLAB website is excellent. And so all the functions that are built into MATLAB are very well documented. They're very well explained on the website. And it's relatively cheap. It's not free, unfortunately. But MATLAB, you can purchase MATLAB for like $100, which is very, very cheap compared to some other softwares out there. Okay. All right. Any questions on why we use MATLAB or just just kind of the reasoning for anything that we're doing? Okay. All right. So now let's get into the nitty gritty of how do we actually do coding, right? So of course we are going to be using code a lot in the class. You guys are going to be writing code. But this is not a computer science type course. And so, this review that I call it is kind of more like a crash course. And so, we'll be going kind of through these things very quickly, but hopefully these are more like refreshers for you rather than, learning these things out for the first time. Okay. Okay. So first let's talk about variables. So variables kind of form the backbone of any kind of computational programming. Basically, variables allow you to label certain entities and use them later for calculation, okay? And so to make a variable, you basically need three different things. And so you need a name for your variable, okay? So that's how you're going to refer to that variable later on in the code. You need a value for the variable, okay? And so that's the value that's going to be stored inside this variable. And then you need to assign it. And so the last component is the equal sign, okay? Okay. So this is a very simple line of code here. This defines a variable called scalar underscore example, and it equals 6. And so, what this is saying is that, we're going to be defining this variable, and it's going to have a value of 6 that we can refer to later. Okay. One small thing, and so when you are writing MATLAB code, it is generally recommended to end every line with a semicolon. Okay. It's not required, so technically you can write MATLAB code and just go to the next line. But if you don't have the semicolon, what tends to happen is that MATLAB will print out every single line that you write to the console, which can be kind of annoying. So generally, it's recommended that you have a semicolon there just to kind of prevent that from happening. Okay. And then you can use variables to store all different kinds of data. And so I think the simplest kind that I think most people think of is you can store scalar data. And so scalar data is just a single value like what we have here. You can use variables to store vector. Okay. So vector is a list of values stored as a kind of a column or a row, or you can store matrix. And so matrix is a multi-dimensional construct, usually 2 dimensions, that stores values within that construct. Okay. Okay. All right. So let's go to MATLAB here. Okay. And let's kind of type some code in just so you can kind of illustrate what's happening. Okay. Now, when you're using MATLAB, one of the very nice features of MATLAB that is not common among different programming languages is this area right here, okay? So this area right here is called your workspace. And so the workspace gives you an organized list of every variable that you've defined in your program, and it tells you their values at this current moment, okay? So let me kind of show you. So right now it's empty because, we haven't written any code yet. So if I define a variable, so let me go ahead and copy that code there. First, let me actually make this font bigger so everyone can see. I forget exactly where. Fonts. Let's make this 18. Okay. All right, much better. Okay, so let me go ahead and write a code here. So let me say scalar example is equal to 6. Okay. So basically, we're defining a new variable called scalar example, and we're setting its value equal to 6. So I'm going to go ahead and hit enter. Okay. And you can see after I did so, a new entry gets populated into the workspace. And so now we have a new variable called scalar example, and its value is 6. Okay. We can make another variable. Okay. And so we can make another variable called 7. And my joke was kind of messed up now because now we put 7 above instead of below. So I can't say 6, 7, but 7, 6. But you can see every time we make a new variable, it shows up in the workspace, okay? So if you're ever confused about your program in terms of, what your values are, definitely refer to the workspace because this is definitely one of the nicest features in MATLAB. Because without, in another programming language like Python or C++, you don't have this. And you're going to have to kind of you're going to have to remember the values of every variable kind of on your own as you kind of write your code, which is not impossible, right? So as you get better at coding, you kind of just naturally do that. But I think when you're first starting out, the workspace is a very valuable tool to have. So definitely keep that in mind and refer to this if you ever get lost. Okay. All right. So we can now use our variables in calculations, right? And so that's kind of the other thing you can do in MATLAB, right? And so MATLAB, some people think of MATLAB as just a very glorified graphing calculator. And so basically any operation you can do in a calculator, you can do in in MATLAB as well, okay? So in this line of code here, we're defining a new variable called scalar operation, okay? And we're going to say that the value of scalar operation is going to be equal to a mathematical expression that involves our variable that we just defined, scalar example, okay? So we're going to say this is equal to 3 times the value of scalar example plus the value of scalar example, okay? Now we can work this out in our head because, this is a very simple expression. So we know that scalar example has a value of 6, okay? And so we plug that in here, we can see that scalar operation should have a value of 24 at the end, okay? Okay, so let's verify if that's true. So let me go ahead and enter that code into our MATLAB here, okay? So let's do scalar underscore operation. Okay. Is equal to 3 times scalar example plus scalar example, okay? Now, if everything worked out well, we should see the value of scalar operation be 24 here in the workspace. Okay. And it is exactly 24, so that is good, okay? All right. So basically any kind of basic arithmetic that you can think of, multiply, divide, add, subtract, you can do that on variables and store the result in another variable, okay? Okay. All right, and so vectors are very similar, and so I'm not going to write this code in just because it's fairly straightforward, but you can use a vector to define a set of values here. So we're defining this vector example to be a vector that's 3 entries, 7, 1, 4. Okay, and you can also do vector operations as well. So you can add vectors together, just like before. Okay, so I'm going to skip this just because you guys have already done the homeworks, so you guys already know how to define vectors and matrices in MATLAB. Okay. All right. So let's talk about some special functions here. Okay. Now, one way that you can define a vector is like the following, right? So like this is what we've been doing, where we basically manually select every single value in the vector. Okay. But sometimes we need kind of special vectors with special entries that are too large for us to kind of define manually. Okay. Okay, so MATLAB has some special functions to kind of make the creation of these variables much more easy, okay? All right, so the first one that we'll talk about is called the linspace vector, or the linspace function. So linspace creates a vector with a specified starting value, a specified ending value, and the number of entries that you want in the vector, okay? So to read this function here, you can see that there's three arguments I get to put in, okay? So the first argument here is the starting point. The next variable, the next entry here is the ending point. And the last entry there, that's the number of points that we want to have in this vector, okay? So basically what this line of code is saying is that make me a vector that has its first entry as 0, its last entry is 10, and I want the vector to have 5 total entries, with every entry in between being equally spaced from the first and the last one, okay? Okay, so let's go ahead and kind of see what that looks like. Okay. So let's say this is linspace underscore example is equal to linspace 0, that's our starting value, 10 is our ending value, okay? And 5 is the number of entries that we want, okay? Okay, all right, so you can see that a new variable has been created in our workspace called linspace underscore example. You can see its values here, right? And so, so for a small vector like this, you can kind of just see the values in the workspace. But for bigger vectors, you may have to double click them in order to view their values. And so for this vector here, we have values of 0, 2.5, 5, 7.5, and 10. Okay, so everything is equally spaced by 2.5. It goes from 0 to 10. Okay, so linspace is going to be very helpful, right? Because eventually, we're going to reach a point where we'll be solving basically finite element equations on kind of a one-dimensional domain. Okay. So we'll probably do this kind of maybe right before spring break, right? And so we're solving for, on domains that look like this, where all the points are equally spaced. And so to kind of very quickly kind of, determine the x coordinate or the location for every point, we can use a function like linspace, okay? Okay, another very useful one that we will be making very liberal use of is the zeros function. And so zeros function will create a vector of a specified size where every entry is 0. Okay, so essentially it's creating an empty vector. That's one way that you can think of it. Okay. Okay, so in this line of code here, we are creating a vector that has 100 entries. Okay, it is a 100 by 1 vector. So this is a column vector where every entry here is going to be 0. Okay. Okay, so let me go ahead and put that in. Okay, we have zeros underscore example equal to zeros 100 comma 1. Okay. All right, so if we look at this vector here, you can see it is a vector with 100 entries, and every single one of them is 0. Okay. Okay. So this is very useful too. So we'll be coming on cases where we'll create kind of an empty vector and then kind of fill in the values later on. So actually, this is one thing we're going to use actually almost right away. You'll see that kind of next week. Okay. All right. Any example? Any questions on this so far? Okay. All right. So let's talk about manipulating variables. And so, once you define a variable, its value is not fixed, and so you can actually change it. Okay. And so the way to change the value of a variable, you just use the equal sign again. Okay. So if you look at this segment of code here, right? So in this segment of code here, we are defining a variable called new variable, and we're going to set its value equal to 7. Okay. And then we're going to change its value. And so later on, we have this other expression here. Okay. We're saying new variable is equal to, this other variable called whodis plus 5/2 times whodis. Okay. And so this basically changes the value of the variable, to whatever's here. Okay. And when you have, two entries like this, remember what I said before, MATLAB is a type of programming language that reads your code from top to bottom. Okay. And so the value that new variable will have will be whatever the latest or the bottommost line of code says. Okay. Okay. All right. So let's take a look. And so I'm going to update the value of scalar example here, right? So scalar example right now has a value of 6. Okay. So pay attention to kind of what's happening over here, right? So let's say I want to change this value to 8. Okay. This is very subtle, but you can see that the value of scalar example has been updated. So even though we have two lines here, right? So we have two lines here that set the value of scalar underscore example. The only one that matters, or I guess the last one that matters here is the last line here, okay? Now, in between these two lines, so in between this line and this line, scalar example does have a value of 6, right? And so, for every operation that you do involving scalar example, the value is still going to be 6, but the latest value is going to be 8. So from here on down, if we write any more code that involves the variable scalar example, it's going to have the value of 8, okay? Okay. All right, so that's fairly straightforward. So that's just redefining a variable. But this last line of code, this last line here is actually going to be very important because we're going to make use of this a lot. Okay, so we can also update the value of a variable. Okay. All right, so to update a value, so let's say we don't want to completely overwrite the value of a variable. Let's say that we just want to update its value. So we basically want to change its value or basically add to it from the old one. Okay, so this notation here, even though it's very compact, there's kind of a lot going on with this line of code here. Okay, so you can see with this line of code here, we are saying that the new variable or the new value of this variable whodis is equal to the old value. Okay, so whatever was there before plus whatever we want to update it with. Okay, so this way, we don't just overwrite the value of whodis. We say that whatever was there before, we're going to add to it. Okay. Okay, so this is very useful because a lot of times, we're going to be updating the value of certain variables in our code, right? And so the first application that comes to mind is, when we are assembling our global stiffness matrix, right? And so if you think back to all the examples we've done previously, right? There was always a certain point in our problems where we're taking our element stiffness matrices and assembling them into the global matrix. And whenever we had entries of our element stiffness matrices that overlapped each other, right, we had to add those entries together, right? So a notation like this or a technique like this can help where, we're not overwriting with the new variable, we're just adding to it, based on our new example, okay? Okay, let's kind of see an example of this in action. So we're going to say scalar example is equal to scalar underscore example, okay? Let's say that we want to add 7 to it. Okay, so this line of code here we're saying is that the new value for scalar example is going to be whatever value was there before. So the value for that was there before was 8, okay? So the new value of scalar example is going to be 8 plus 7, okay? So we're basically taking 7 and we're adding it to whatever value was there before. And so if we do this correctly, it should equal to 15 at the end of the day, okay? Okay, so I ran that line of code and you can see that scalar example does indeed have a value of 15, excuse me. Okay, so keep this in mind. So this update notation is something we're going to make use of pretty liberally in this class, to basically update just whatever value was there before. Okay. All right, any questions on this so far? Okay, good. Okay. All right, so variables, variables we're going to be making use of quite a lot in our code, right? So basically, if you know how to use variables, then you're in a good spot, okay? So the first use of a variable, which is commonly used, is to basically store any kind of important parameters for the problem, okay? So let's say that, we have a program that's going to be computing the area of a circle, and so we need a variable that is going to store the value of the radius, okay? And so we can say that radius is equal to 4, and then later on, we can compute the area as, pi times the radius, okay? Okay, another important use for variables is to store values that are used in calculations, okay? And so in finite elements, we are doing a lot of calculations in our code. And so a lot of times it's useful to use variables to store the values of these calculations that we can then use later on, okay? Okay, so one important tip that I can give you for variables is to use descriptive names, okay? And so if you notice, in every variable that I've written so far, I've used a fairly verbose name here, right? So I'm not just saying, A is equal to this or B is equal to that, right? So try to avoid situations where you're using single letters for your variable names, okay? Because what's going to happen is that, when you write a program, especially when you write a big program, is that it's not going to work the first time, right? And so you're going to need to debug things and find out what's going on. If you have variable names that are very descriptive, right, that tell you exactly what they are doing, it makes your debugging worlds easier, okay? But if you use names that don't really mean anything, so you use X and Y, or maybe something, or maybe a variable name that's written out of frustration, right? It's going to be much more difficult to debug your code and find out what's going on, okay? So I highly recommend you, definitely use, verbose variable names. It doesn't have to be too verbose, right? And so it doesn't have to be, don't write an essay for a variable name, but it should be enough to describe exactly what that variable is meant to do, okay? That's always just kind of good coding practice, kind of 101, right? And so I know on the one hand, it is annoying to type, long variable names, but trust me, it'll make your life much easier when you're trying to debug, okay? Okay. Any questions on this so far? Okay. All right. The one thing I don't like about slides is that I don't pause to write, and so my voice is really tired. Okay. All right. Let's talk matrices. So matrices, we've already seen these, and so I'm just going to go through this very quick. But you can define matrices in MATLAB as well, right? And so all of you have done the homework, so you kind of know exactly what this is, right? So you basically define the matrix row by row. You use commas to separate entries on the same row, and use a semicolon to go to the next row, okay? Another way to define matrices is to make use of our zeros function that we had before, okay? Right, and so we're going to make use of this notation a lot too, even though this looks a lot more cumbersome. So this is, 10 lines of code instead of 1, right? But this allows us to kind of specify each individual entry much more easily, right? So the technique for this is to first create an empty matrix, right? So basically use the zeros function, create a matrix of all zeros. So this is creating a 3 by 3, and then specify the values for each of these variables kind of 1 by 1, okay? Okay. All right. So why would you want to do this? And so, in finite elements, we're going to run into cases, especially when we assemble, where the vast majority of our entries in our matrix are going to be 0, okay? And so I'm thinking of, maybe like our global stiffness matrices, that are maybe like, 12 by 12 or, maybe 20 by 20, right? So the vast majority of those entries are going to be 0. So it doesn't make sense to define our matrix like this. And so it kind of helps to have a method like this where we can define individual entries, where, we kind of specify which are the non-zero entries, okay? Oops. Okay, and the same update notation can be used for entries in the matrix as well, okay? So the same update, paradigm that we had before, we can use that for specific entries in the matrix, okay? Okay. All right, so I'm going to skip this as well. So this is, because, we've all kind of done this before. So you can use MATLAB to solve a linear system of equations, right? And so, we've all done this just because, you guys have done the homework. But basically, you define a matrix, you define a vector, and then you use a special backslash operation, just like the following here. Okay. All right, so all that is what I would consider to be kind of basics in MATLAB, okay? Okay, now we actually get to the programming part, which I think this is kind of when people start to kind of struggle with, okay? Okay, all right, so let's talk about if statements first, right? So if statements are what we call conditional programming, right? Because oftentimes, when we write a program, we want the program to do a certain thing in a certain situation, but maybe we want to do something else in another condition, okay? And so the way we can do that is to write an if statement. So the anatomy of an if statement looks like the following, okay? Okay, so an if statement is, we do if, so if is the key word. Next to the if, we're gonna put our, what we call a check condition, okay? And our check condition is a statement that can either be true or false, right? And so in programming terms, this is what we call a Boolean expression, okay? Right, and so you can think of the check condition as almost like a question, right? And so you can ask a program, is this true or is it false? Okay. So if the check condition is true, right, then we execute whatever is inside the if statement, okay? But if the check condition ends up being false, then we don't execute. We basically just skip over everything in the middle. Okay. Okay. All right. So let's do a couple of examples here. Okay. All right. So first we have this section of code here. Okay. All right. So we have, let's say, a variable called needs correction. Okay. So if the value, excuse me, if the value of needs correction is less than 5, then we correct it and we say the needs correction variable is equal to 5. Okay. Okay. So let's see what this looks like in practice, just so my voice can get a break. Okay, so for if statements, we're gonna move away from the command window. We are going to use a script. Okay. Okay. So let's see. Let's write that code here. So let's say, well, let me kind of clear everything first. So clear all, close all. So you'll see. Okay. So I put this at the top of every code, just to make sure our workspace is clean by the time that we're working. Okay, so let me kind of copy that code that we had there. So let's say needs correction equal to 3. Okay. So if needs correction is less than 5, okay. We have to include our end here, right? So end is kind of the end for our if statement, okay. Right, so that specified, that basically tells the program that, this is kind of the end here, so we don't need to go any further. Okay. Okay. So if needs correction is less than 5, then we say needs correction is equal to 5. Okay. Okay. So based on this code here, we can see kind of the very basics of an if statement. So here we have our check condition. So we're going to check to see if the value of needs correction is less than 5, right? Which in this case it is, right? And so if we start with the value of 3, then needs correction is going to be 3, which indeed is less than 5, right? And so we're then going to execute the code inside the if statement right here, okay? Okay, so if I run this code, then you're going to see that the value of needs correction is going to be set to 5. Because even though we initially set it as 3, we then override it by this if statement here. Okay. Okay. And so you can see, the value of needs correction is indeed 5. Okay, just like we predicted. Okay. Okay. All right, but we can also change this. So let's say that we're going to change this value to 8 here. Okay. All right, and so if we update the starting value for needs correction to 8, right? We then go into the exact same if statement, right? So we're going to check to see if the value of needs correction is less than 5. But if we set the value of needs correction to 8, that means this is going to be false. And if our if statement is false, that means we do not execute whatever's inside the if statement. We then just kind of move on to the end. Okay. And so if we run this code, our needs correction variable should still have a value of 8. And indeed, it does. Okay, so we run the code. We can see that needs correction has a value of 8. Okay. Okay. So that's if statement. So if statement is a central kind of programming construct. So we're going to make good use of it. Any questions on if statements? Okay. Okay. All right. Let's add some complexity. So what if we were in a situation where we wanted to check multiple conditions, okay? And we want to do different things depending on those different conditions, right? So we can add to our if statement. And so we can add to an if statement with an else if, okay? So an else if is a statement that's embedded within an if statement, okay? And it basically gives you a way to kind of do different things depending on the situation, okay? All right, so to read an if-else if statement, we're basically just going to read it from the top to the bottom. So we're going to check first condition 1, right? If this is true, then we're going to execute what's right, the code that's right under the if statement, and we're going to ignore everything else, okay? But if condition 1 returns false, then we're going to check condition 2, okay? And if condition 2 is true, then we're going to execute whatever's underneath the else if, okay? But if both condition 1 and condition 2 are false, then we don't execute any of this code and we just kind of skip over it. Okay. Okay, so let's look and see what this looks like in practice. Okay. Actually, let me just kind of copy this code here. Okay. I said it's greater than 11, right? Let's check. Greater than 7. Okay. All right, so this is an example of an if statement, right? So we have a variable here needs correction. Okay. First, we're going to check if the value of needs correction is less than 1. So if the value of needs correction is less than 1, then we're going to set its value to 1. Okay. Next, we're going to check to see if needs correction is greater than 7. So if it's greater than 7, then we're going to assign its value at 7. Okay. Okay, so based on this code here, what do you think is going to happen to the value of needs correction by the end of this code? Right. It should have a value of 7, right? Because the first condition is going to be false, second condition is going to be true, and so that means we're going to execute this line of code here. So let's go ahead and run it. Okay. And you can see indeed that needs correction does have a value of 7, okay? Because the first check condition returned false, the second one returned true, and so we execute whatever is right underneath there. Okay. Okay. All right. So let's do another example with this. Okay. So let's say that needs correction instead starts with a value of 0. Okay. So in this situation, the first condition here is going to be true. The second condition here is going to be false. And so the value for needs correction should be 1 at the end. Okay. Okay. So let's go ahead and run the code. Let's hit in here. Okay. You can see that needs correction does indeed have a value of 1. Okay. So, we only execute there. Okay. But let's say that our needs correction variable is right. It doesn't satisfy either one. Okay. So in this situation, the first check condition is false. The second check condition is false, right? And so our needs correction here, we don't execute anything in the if statement at all. And so the value for needs correction should still be 5, according to this code here. Okay. Okay. So we ran the code, and so indeed we do have a value of 5 for that variable. Okay. Okay. All right. Any questions on this so far? Okay. I think the thing with MATLAB, where like each individual component of programming is not too difficult. It's more in kind of using it in kind of a complex problem that is kind of the difficult thing. Okay. All right. So the last kind of entry, or the last kind of thing that you can add to an if statement, is an else. Okay. So an else statement is something that the program will execute no matter what happens. Okay. So let's say that, we have our if statement here, and let's say that, both of the conditions return false. Okay. So the else statement is a way for this, if statement to still execute some code, in case that the first two conditions fail. Okay. Because previously, if we look at our example here, right? Previously, if both of the conditions failed, then we just basically ignore everything here, and no code gets executed basically within the if statement. Okay. All right, but if we add an else, then we can still execute something, right? Even if the others fail. Okay. All right, and so basically we're checking here if needs correction is less than 1, then we set its value to 1. If needs correction is greater than 7, then we set its value to 7. But if both of those fail, then we at least set the value of needs correction to 4. Okay. And we can see that's exactly the case here. Okay, so needs correction has its value equal to 4 because then we hit the else here. Okay. Now remember the thing with if statements is that only one section of the if statement ever gets executed. Okay. There's never a situation where you're executing code from multiple parts of this multiple parts of this if statement here. Okay. Let me kind of show you why. Okay. All right. So you can see I've updated this code here. So you can see here that if needs correction starts with a value of less than 1, we then set its value equal to 12, okay? Now, technically 12 is greater than 7, and so you would think that, if you're reading this if statement from top to bottom, that needs correction will have its value equal to 7, right? But remember that we only execute just one section of the if statement for any given if statement here, okay? And so because we executed the top portion here, no other part of this if statement is going to get executed. So if we run this code, needs correction should have a value of 12. Okay. Oh, I need to update the initial value. So let's say that this is 0. Okay. Okay. And you can see here that is indeed true. So even though, after the first if, right, technically this this condition here is now true, right? But the program doesn't even see it because, it says that, we have an if statement. Our first condition was true. Okay. I only need to execute whatever is in here and then ignore everything else, okay? So that's one very important tip for the if statement is that only one section of the if statement ever gets executed, no matter if the conditions change, no matter if the later Booleans are true, right? It's just the first true condition that it hits, it'll execute that code and then exit out of the if statement, okay? All right, any questions on this? Okay. All right. So that's if statement. So the next kind of programming construct to check out is the for loop. Okay. Now the for loop is a way for you to repeat code. Okay. All right. And so it's going to be very common in this class that we are going to want to repeat sections of code. Okay. So the way to do that is to use a for loop. Okay. And so the anatomy of the for loop is the following. So we have for, right? So for is our key word. Next, we have the index. And so this is a variable that's going to keep track of which iteration of the for loop that we're on. Okay. Then you set this equal to. Okay. Next thing you set is the starting value for the index. Next thing is the last value. So that's the stopping value. Okay. And then it's going to do whatever is inside the for loop. It's going to execute that on repeat. Okay. Okay. All right. So the way to kind of read this is that, we're basically going to be having our for loop start at a value of start. It's going to stop at a value of stop, right? And then for every basically increment in between, it's going to be executing that code, okay? Okay, so a very common application, so we're going to be using this a lot in this class. A very common application of a for loop is to visit and assign every entry in a vector, okay? Okay, so let me go ahead and write this code here just so you can kind of see it. Okay, actually, let me go ahead and delete this. Okay. So let's say that we have vector example is equal to zeros. Okay. And let's make it a 10 by 1 just to make it a bit more interesting. Okay. Okay. So if we start with a vector like this, and let's say that we want to assign the value of every entry in the vector, right? That would be very cumbersome to do kind of manually. So we can do vector underscore example at 1 is equal to 2, okay? We do vector underscore example at 2 equal to 4, vector underscore example at entry 3 is equal to 6, okay? Right, and so we could keep doing this, right? And so there's nothing wrong with that. It's just very cumbersome to do, okay? So the more efficient way to do this is to use a for loop to visit every entry in this vector and assign its values. Okay. Okay. Okay, so let's write a for loop. So let's say for, okay. We need our loop variable. So our loop variable we'll call index. Okay. By the way, it doesn't have to be called index, and so you can give it another name. Okay. So very commonly, you'll see me use the index I. Okay. So remember I said, usually I don't like to use single letter variable names, but for loops, generally it's okay, just because, the for loop, that variable is only going to live inside that for loop. Okay, so we're going to say, let's say that we want this for loop to visit every single entry in vector example. So we're going to start at a value of 1, right? And then we're going to end at the length of the vector, which is 10. Okay. Okay. Okay, so the way to kind of use this loop index is that basically every time this loop iterates, right? So every time this loop kind of reaches the end, the value for I is going to increase by 1 until it reaches 10. Okay. Okay. Actually, let's do something interesting. Let's do I squared. Okay. Okay. So what this loop is saying is that, on each iteration of the loop, so each time this loop executes, we're going to visit the ith entry of the vector, right? And we're going to set its value equal to I times I, which is the square of that variable. Okay. Okay, and this is going to continue. They're going to repeat this 10 times, right? And so by the time this this code executes, this vector example here, all the values in this vector will be populated, and they'll be populated by squares of the loop index. Okay. Okay, so I ran the code. This is the result. Okay, so you can see that every entry in the vector here is defined by the square of that index. Okay, so we have 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Okay. Okay. All right. So this is a very, very common, application for us, right? And so we're going to have, in finite elements, we have, lots of matrices, lots of vectors that we need to assign values for. And usually the most efficient way to do so is to use a loop just like this. Okay. Okay. So here is an illustration of kind of what's happening within the loop. Okay? So because, when you look at a line of code like this, right, a lot of things are actually going on in this loop, right? But actually, let's kind of, talk it out and kind of see what's going on, right? Because, the loop doesn't happen all at once, right? The loop literally repeats, right? So there's a first iteration, a second iteration, third iteration, and the value of whatever vector that you're changing in there is changing dynamically, okay? Okay, so of course, this is kind of the explanation for this code right here. Okay, so you can see that with every iteration here, the loop vector has its values being updated. Okay, because we started with a zeros vector, right? So we started with a vector with all zeros. Okay. Okay. And then each iteration of the loop, we're basically overwriting one entry here, right? So on the first iteration, we're overwriting the first entry to 2, okay? Second iteration, we're overwriting the second entry to 4, then 6, then 8, then 10, okay? All right, and so this kind of schematic here is helpful for that, okay? So if you're ever having trouble kind of debugging a loop, think about what a loop is doing and really try to visualize, what's happening on each iteration of the loop and try to make sure that, you're setting things correctly. All right. Any questions on this? Okay. Good. Okay. So let's talk about nested for loops. And so this is kind of the exhibit meme. So it's we heard you like loops. We put loops inside your loops. Okay. So for nested for loops, this is useful where you may have to have multiple loop indices. Okay. So the way to read this is that, you have an outer loop and an inner loop, okay? Right, so for every time the outer loop iterates, right? So every time the outer loop kind of goes by 1, the inner loop will make a full cycle, right? And so, literally we're saying we want to repeat this code, X amount of times. And then, if we say we're going to repeat this code Y amount of times, then the amount of operations is X times Y, okay? Okay. So for nested for loops, the analogy that I like to use is think about the hands on a clock, right? So the outer loop is like the hour hand and the inner loop is like the minutes hand, okay? So every time the outer loop kind of increments by 1, so every time, the hour goes from 1 hour to the next, the inner loop or the minutes hand will make a full rotation here, okay? And of course, you can think of a very obvious application for this, which is assigning entries in a matrix, okay? Because remember, for a matrix, we have 2 indices, right? So we need the row and the column, right? So a nested for loop like this is a very easy way to kind of loop over every entry in a matrix and specify it as something specific. Okay. All right, so that's exactly what we do here, okay? So let's say we have this section of code. We have a nested matrix, and so that's going to be zeros, 3, 5. Right, so this creates a matrix of all zeros with 3 rows and 5 columns, okay? And let's say that we want to basically modify every entry in that matrix, okay? Okay, So the way we could do this is that, we can have two for loops. And so let's say we have one for loop that loops over the rows, okay? So we have 3 rows, and so this loop is going to go from 1 to 3. We have another loop that's going to loop over the columns, and so that loop is going to go from 1 to 5, okay? And then we're going to assign a value based on those indices, okay? So, we're going to say that the nested matrix at the row given by row index and the column given by column index is going to be equal to a variable count, okay? And we're going to increment the value count by 1 each time we iterate on this loop, okay? Okay. All right, so this is a very efficient way to kind of visit every entry in a matrix and then, access its value and update its value, okay? Okay, so you run this code, right? And then you get the matrix like this, okay? Now, in this example here, I've kind of introduced another kind of important programming construct, which is the concept of a counter variable, okay? Now, in a loop, a loop naturally has a counter variable, which is the loop index, right? So we know the loop index is going to increment by 1 each time the loop executes, right? But sometimes, you may have situations like this, or maybe you have multiple loops inside the loop, right? But you want it to count every time you may do a calculation, right? And so sometimes it's useful to store kind of an external counter variable and then, control its increment or control its value within the loop itself, okay? Okay, and of course, the ultimate kind of a combination of everything that we learned today is to put an if statement inside a for loop, okay? Now, this is kind of where if statements really shine, because oftentimes, we have a for loop, maybe we want to do something different on certain iterations of that for loop, okay? Okay, so for example, let's look at this example here, okay? So for this example, you can see that we have a vector here. So we're going to start with an even vector. It's going to be a 20 entry vector, okay? And let's say that we only want to assign values on every other entry in the vector, okay? Okay, so the way we do this is we can put an if statement here, okay? So this if statement is going to check and see if our index is a multiple of 2, okay? Now, this mod function is something unique, and so that's probably something you haven't seen before. Okay? So the mod function is a function here that does integer division, okay? So it does division of both the entries here, okay? Right, so the way to use mod is you provide it with two values here, A and B, okay? And then what mod is going to do is going to do A divided by B. But instead of giving you the result of A divided by B, right, it's going to give you the remainder instead. Right? So this is very useful in certain situations. So, if you read this code here, we can say if the remainder of the division between the loop index and 2, right, if that's 0, right, and so this basically tells you that we're at an even number, right? Because if you take any even number, you divide it by 2, right? You're going to get a perfect division. So you're going to have no remainder, okay? And so if that's true, then we assign an entry to that vector, okay? So we say even vector at vector index is equal to vector index, okay? And the result of this loop is given below here, okay? So you can see for every odd entry here, so for 1, 3, 5, 7, 9, 11, right? These are all zeros because we skipped over them because of the if statement. Whereas every even entry, the 2, the 4, the 6, the 8, the 10, the 12, right? These have assigned values because the if statement here returns true, okay? Okay, so the if statement inside the for loop is a very powerful tool and one that we're going to make use of quite a bit in this class, okay? Okay, any questions on this? Okay, so the next thing I have for you is to, is an example, right? So I'm gonna have you guys work on this for the next 5 minutes while I go get a drink of water because I am dying of thirst right now. But I want you guys to write code that assigns the values of an empty 5 by 5 matrix according to this criteria, okay? Okay, So the first row in the matrix, I want the first entry to be 2, and then every subsequent entry should be 4, 6, 8, and so on. Okay. For the second row, I want the starting value to be 3, and then each subsequent entry will be 3, 6, 9, 12, so on and so forth. Okay. Third row, and so on and so forth. Okay. Oh, that was the answer. Don't look at that. Okay. But let me kind of show you what the matrix would look like. Okay. Okay, so first row in the matrix, I want it to be 2, 4, 6, 8, and 12. Okay. Next row is going to be 3, 6, 9, 12, 15. Okay. The next row is 4, 8, 12, 16, and 20. Okay. And then fourth row and fifth row, same logic. Okay. So you should be able to do this. You should be able to do this with a single for loop and a single if statements within the for loop. Okay. Let me just check and see. Oh, you can do this with a nested for loop. Excuse me. So the approach for this is a nested for loop. And you may use a counter variable. Okay. Okay, so those are your hints. I'm gonna go get a drink of water, and we'll come back in 5 minutes and we'll discuss the result. Okay, but definitely work on this, and so don't twiddle your thumbs for 5 minutes just because I'm gonna give the answer in 5 minutes, right? The thing with programming and the thing with MATLAB is that you only get better when you try it. Okay, and so you can't just listen to the lecture for an hour and expect to be magically better than MATLAB. Okay, at this point, you are the same at MATLAB as you did when you started the lecture today. So the only way you're gonna get better is by trying it yourself. Okay. So try this example. Doesn't matter if you get it right or wrong. This is just a work an example in class, and then we'll discuss the example in 5 minutes after I get some water. Okay. And by the way, there's multiple ways to do this too. So there's not just one way. So there's if you come up with a different solution than what I did, that's perfectly fine too, right? That's the thing with programming is that there's what they say, multiple ways to skin a cat. I hate that saying because I have 2 cats, but I think that's the one that everyone knows. Okay. All right. So it's been about 5 minutes. So let's look at the solution. Okay. So before we look at the solution, let's talk a little bit about kind of the logic that I use to approach to get that solution. Okay. Okay. All right. So first thing we see here is that we need to create an empty matrix, right? And so that tells us we're going to use a zeros command, right? So we're going to use zeros, 5 by 5, right? So hopefully everyone at least had that part, right? Because whenever you need to create an empty matrix, that's the best way to do it. Okay. Now we're in a situation where we need to assign every single entry in the vector in the matrix, right? And so the best way to visit every entry in a matrix is by using a nested for loop. Okay. Right. And so that's the, that's kind of the bones of the solution here. Everything else is kind of like just the logic and the particulars of this problem. Okay, so let's look at the solution and let's take a look. Okay, so here's the solution. Okay, so you can see that we start with a empty matrix, just like I mentioned. Okay, and we have our nested for loops. We have one for loop that's looping over the rows. We have another for loop that's looping over the columns. Okay. Now here's the interesting part, right? So we know that the matrix has to go 2, 4, 6, 8. So every row in the matrix, you're basically increasing the amount of increment by 1. Okay. Okay. And so you can see here that outside of the inner loop, we have a line of code here that says count is equal to row index plus 1. Okay. Now, the position of this line of code here is very critical. And so it's very kind of easy to overlook. Okay. But this line of code here, you can see is going to execute before every inner loop executes. Okay. This was a mistake. Okay. Okay. So why is that important, right? So this line of code here, and you can see later on, we're going to be modifying the value of count, right? You can think of this line of code here as basically resetting the value of count before you get into the inner loop again. Okay. Right, because we're basically saying that our inner loop here is going to be, changing the value of count, but before we enter the inner loop again, we need to reset its value to something else. Okay. Okay. All right. So with that said, if we go through kind of the first iteration of this loop, so the first iteration row index is going to have a value of 1. Okay. So for the first iteration, count is going to be reset to a value of 2. Okay. And then we're going to loop over the columns. Okay. So we have another for loop. We're looping over the columns, right? And so that's going to allow us to access the row and the column of that row. We're going to set its value equal to count. Okay. And then, right, for the inner iteration of the loop, for the inner loop, we're going to update the value of count depending on, depending on the row that we're on. So, this here kind of executes the logic of, every entry in the row kind of increments by a different number. Okay. So we say that count is equal to count, right? And so we're updating here. We're not overwriting, plus the row index plus 1. Okay. Where row index, remember, is going up, with each row. Okay. All right. And so if you walk through that logic there, then you can kind of see that it produces this matrix exactly here, right? Because every time you go to the next row, right? So every time the outer loop iterates, right? Your row index is going to be increasing by a value of 1. And so your starting value for count is going to go up by 1 as well, right? So that's why we start by 2, 3, 4, 5, and 6. Okay. And then because the value of row index is increasing, that means the amount that we're incrementing count also goes up with each iteration as well. Okay. So I like this example because, it uses a counter variable and it kind of illustrates kind of how you can kind of use the loop indices to your advantage in certain problems. Okay. Okay, so I have another example for you to work on. Okay, so again, I'm going to give you guys 5 minutes to work on this. Okay, So for this one, I want you to start with an empty vector of 25 entries, okay? I want you to loop over every entry of the vector and modify their value according to the criteria, right? And so if the index for the vector is an odd number, then I want you to set its value equal to 1. If the index is a multiple of 4, then I want you to change the value of the entry to 4. And in all other cases, I want you to change the value of the entry to 24, okay? Okay, so for instance, right? So let me kind of write a vector just like this, okay? So for every odd number entry, we're going to have a value of 1, right? So we're going to have a 1, okay? Because the first entry is an odd number, so that's going to be 1. Okay? For an even number entry 2, right? 2 is even, so it doesn't fit the first condition here. It's not a multiple of 4, and so that means that the value for the second entry is going to be 24. Okay. Third entry here is going to be an odd number, so we're going to set its value to 1. Okay. Fourth entry, it's not an odd number, but it is a multiple of 4, and so we're going to have a value for 4 on the fourth entry. Okay. Fifth entry is 1. Sixth entry, even number, not a multiple of 4, and so it's 24. Okay. And then 1, 4, and then so on and so forth. Okay. Okay. So you should be able to write this code, and it's fairly straightforward. And so obviously you're going to use a for loop. Okay. Okay. And then hopefully you can kind of tell from the language here, but you're also going to have an if statement. Okay. I guess specifically it's going to be an if else statement. Okay. Inside that for loop that interacts with the loop index. Okay. All right, so I'll give you guys, I do want to cover plotting today, so I'll give you guys maybe 3 minutes to work on this, and then we'll talk about the solution right after that. Okay. Okay, all right, so let's take a look at the solution. Okay, so you can see here that we have the code that executes this. And so, first thing you can see here is that we're creating a zeros vector, right? So we're creating an empty vector of 25 entries, okay? And we're going to loop over every single entry. So we have a for loop. That's going to go between 1 and 25, okay? And you can see here we have an if statement that goes through every, every condition here, right? So first thing we're going to check and see, first we're going to check and see if our entry is odd or if our index is odd, okay? And so for index odd, we take basically the mod of the index divided by 2. If the remainder is 1, then we have an odd number, okay? And so if that's the case, we set the value of that entry equal to 1, okay? Next, we check to see if the entry is a multiple of 4. And so to do that, we use mod. The index, we divide by 4 if the remainder is 0. Okay, then we set its entry to 4. In all other cases, okay, we're going to set the entry equal to 24. Okay. All right, so this is a good example of using an if statement within a for loop, doing something different on every iteration. Okay, which is oftentimes what we do with the if statement in a for loop. Okay. Okay. Any questions on this so far? Okay, so last thing I want to show you, and we'll finish the tutorial in one day, which is great, is plotting, right? And so plotting is one of the very nice features within MATLAB as well, as a very easy way to kind of visualize your data. Okay. Honestly, there's no other programming language, scripting language that makes it as easy as MATLAB to plot stuff. Python gets close, but Python I find is a little bit cumbersome compared to MATLAB. MATLAB just makes it very easy. Okay, so to plot things in MATLAB, we're going to use the function called plot. And plot, technically you can plot just one vector, but typically when you use plot, you're going to supply 2 vectors to it, right? So you're going to provide a plot or vector for the x values and a vector for the y values. Okay. And then it's going to create a plot which pairs every single entry. So, the first entry of this vector is going to be paired with the first entry in that vector. That's going to be a coordinate in your XY plane. Okay. Second entry of this vector is going to be paired with the second entry of that vector. That's going to be the second point here. Okay. And so on and so forth. And it's going to connect everything with a line. Okay. Okay. Now, the main thing to know here is that when you're using plot, is that both of these vectors have to be of the same size, right? If they're not the same size, then MATLAB's going to throw an error because it's you have mismatching sizes here. Okay. Okay. So as an example, we have our function here. So let's say we want to just plot a simple quadratic function, right? So we say that x is going to be x is going to be a vector. It's going to be linspace, and so it's going to be a vector that starts at 0, ends in 5. We want 100 entries in between those two, okay? Y is just going to be x squared, okay? And we're just simply going to plot x and y, okay? And so that creates the following plot. You can see we have our characteristic parabola, okay? And we have some extra lines of code here to provide some extra kind of, stuff here, right? Because usually when you make a plot, usually you want to give it a title. Usually you want to label the x and y axes, and so that's all that does, right? And so there's nothing, no calculations being done. That's just kind of just for decoration, I guess you can say, or labeling, right? And then this line of code here is useful as well, right? So oftentimes in your code, we're gonna make multiple figures, and so it's good to kind of pre-open a figure. So this kind of pre-opens a window in your MATLAB called figure 1, okay? And then it's going to plot it on that figure. Okay. Okay. All right. And so that's our crash course in MATLAB. And so, before we end today, I want to give you kind of the number one advice that I always give to people in MATLAB, right? Or any programming language. So programming is, you can think of programming as simply just talking to your computer in terms of giving them instructions, right? And so if you're ever at a point where you're debugging your code, it's doing something that you don't expect or you don't know what to do, think about the tasks that you want your computer to do, and think about how you can write instructions in order to get your computer to do that. Okay. And if you're having trouble, and so let's say your code's not doing something that you want it to do, just simply talk it through. So, read your program from top to bottom and kind of, translate your code into human language, right? And so if you do that, then I think it's easier to kind of debug stuff, because that's all that code is. Code is just a list of instructions for your computer to do, right? And so just like we as humans like to receive clear instructions that are non-ambiguous, right? The computer is exactly the same way, right? So the computer is only going to do exactly what you tell it to do. And so you want to make sure that your instructions are clear, your variable names are descriptive, and the calculations are all correct. Okay. Okay, so when we come back on Thursday, we'll actually start applying this. And so we'll actually be implementing a code to do our frame calculations. Okay, so this is kind of the follow-up to the homework. And so we'll write a code to basically do the homework for you. Okay, so some of you have done this already, which is great. But I think, I think walking through that module, I think will be helpful for everybody. Okay. All right, so thank you everyone for coming today. With anything in MATLAB, it's practice, practice, practice. And so, we'll definitely get a lot of that as the class goes along. Hope you guys have a good rest of the evening, and I will see you guys on Thursday. See you, Mario. How's it going?
Crazy.
The fillable form.
Oh, I haven't looked at it yet. Does time work?
Yeah, I haven't had a chance to post the solutions yet, but they're going to go up soon. Just so that I know you guys need them to study for the midterm. So I'll get homework 1 solutions probably up tomorrow, and then homework 2 solutions, I'm just going to check them just to make sure everything is right, and I'll probably post them later this week. Yep. All right, have a good night. Good night, Lewis. Good night, Jennifer.